This is our lesson on 7.2. Use the converse of the Pythagorean theorem. Use the converse of the Pythagorean theorem. Do you guys remember converse, inverse, converse, contrapositive? So if P, then Q becomes what? If Q, then P. It's the flip-flop. So the converse of the Pythagorean theorem, instead of a squared plus b squared equaling c squared, if a squared plus b squared, if it's a right triangle, then a squared plus b squared equals c squared, correct? That's Pythagorean theorem. If it's a right triangle, then that happens. So the converse would be if a squared plus b squared equals c squared, then it's a right triangle. So instead of it being, hey, it's a right triangle, solve for missing side, it'll give you the sides and say, if these sides satisfy the Pythagorean theorem, then we can conclude it's a right triangle. So tell whether the given triangle is a right triangle. So we're doing the converse. We're trying to prove that it's a right triangle instead of starting with the fact that it's a right triangle. So what do we need to do? We need to see if this squared plus this squared equals that squared. So 9 squared is 81. 15 squared is 225. How do I do this squared? It would be 3 squared is 9, and square root of 34 squared is 34. So 9 times 34. 9 times 34 is 306. 81 plus the 225 is 306. Since they equal each other, then yes, this is a right triangle. So yes, this is a right triangle. How about this one? How do I know which one's my hypotenuse? My hypotenuse is always the largest number. So this one goes by itself. So 26 squared better equal 22 squared plus 14 squared. Let's see if it does. 26 squared is 676. 22 squared is 484. 14 squared is 196. Add those together, and you get that 676 does not equal 680, so it is not a right triangle. Tell whether the triangle with the given side lengths is a right triangle. So the first thing you need to do is identify which one is the largest number. This 8 is the largest, 14 is the largest, and square root of 61 is the largest. How do I know that square root of 61 is the largest? 8 times 8 is 64, so it's just under 8. 7 times 7 is 49, so it's greater than 7, less than 8. So it's definitely the largest number. Do you guys see how I did that? Square root of 3 times 4 is 6.9, and 6.9 is definitely less than 8. So now we've identified our hypotenuse. So is 4 squared plus 4 rad 3 squared equal to 8 squared? 4 squared plus 4 rad 3 squared, is that going to be equal to 8 squared? 16 plus 4 squared is 16 times square root of 3 squared is 3 equals 8 squared. 16 times 3. What do you guys got? 48. So 16 plus 48 is what? $64 equals 64. So yes, it's a right triangle. How about here? We have 10 squared plus 11 squared equals 14 squared. 100 plus 121 equals 14 squared. 196, right? Double check me. Okay. 221 equals 196. Nope, not a right triangle. Eventually this cough will go away, I promise. Hopefully. 5 squared plus 6 squared equals the square root of 61 squared. 25 plus 36. Is 25 plus 36 61? So yes, it's a right triangle. Are we okay? Can segments with the lengths of 4.3 feet, 5.2 feet, and 6.1 feet form a triangle? If so, would the triangle be acute, right, or obtuse? So first off, are they allowed to form a triangle? Any two sides must be greater than the third. So if I take my smaller two sides, are they greater than the third? Yes. So yes, it can form a triangle. If so, what kind of triangle? So we always take our hypotenuse squared first. 6.1 squared, and we compare it to our 4.3, to our legs squared, the sum of our legs squared. So we basically set it up for Pythagorean theorem, but we don't know what symbol goes here until we do the math. So 6.1 squared, 37 and 21/100ths. 4.3 squared, 18 and 49/100ths. 5.2 squared, 27.04 and 4/100ths, plus 18.49, we get 45 and 53/100ths versus 37.21. My alligator eats what's greater. So my alligator's going to eat the 45. The alligator wants $45 versus $37. He's hungry.
Is it because you're a Gators fan?
I am a Gators fan. I went to the University of Florida. The alligator eats what's bigger. So, when we are comparing, is it right, obtuse, or acute? If it's a right angle, then it's going to be equal, right? If it's obtuse, it's going to be greater than. Obtuse, big, large, greater than. And if it's acute, it's like a cute little baby, it's less than. So as long as you start with your hypotenuse to the left, then these rules apply. As long as the hypotenuse is on the left, then if they're equal, it's right. If it's I can't even speak. If it's obtuse, it's going to be greater than, and acute is less than. So in this one, we have a less than. So it's a cute little triangle, like a cute little baby. All angles are less than 90, right? Greater than 0, less than 90. You are part of a crew that is installing the mast on a catamaran. When the mast is fastened properly, it is perpendicular to the trampoline deck. How can you check that the mast is perpendicular using a tape measure? Any ideas, guys? I heard someone. How about we measure a point up here, right? And so we would measure the height, and then we would pick a point out here and check and see whether or not this makes a right angle, if it's a right triangle, right? So we would know the length, we would know how far out this is, and then if we use this distance, we know whether or not it is a right angle. So, to show the line is perpendicular to a plane, you must show that the line is perpendicular to two lines in the plane. And we would test one more point. So if we measured, like if we use numbers that are easier, so if we measured 3 feet up, we'd have a 3, 4, 5 triangle. So 3 feet up and measure over 4 feet, this length between these 2 points better be 5. And we need to do that in 2 places just to double check, and then we'll be good. We know that it's installed properly. Show the segments with lengths 3, 4, and 6 can form a triangle and classify the triangle as acute, right, or obtuse. All right, so 3 and 4, is the sum of the 2 smaller ones greater than the third? If it's a triangle, the sum of any 2 sides must be greater than the third. 3 plus 4 is 7. Is 7 greater than 6? Yes, so we know that it can form a triangle for sure. Well now, what kind of triangle? 6 squared versus the sum of 3 squared and 4 squared, right? The sum of the legs versus the hypotenuse. So your hypotenuse squared, 6 squared is 36. 3 squared is 9, and our second leg, 4 squared is 16. 9 plus 16, 25. So 36 is greater than 25. If it's greater than, it is obtuse. Good job. So this is an obtuse triangle. What if in example 3, you could use triangles with side lengths of 2, 3, and 4 to verify that you have perpendicular lines? Explain. Could you use 2, 3, and 4? What is 2 plus 3?
5.
5. Is 5 greater than 4?
Yes.
Yes, so that's good. Now we just need to check, is this a right triangle? So we know that it can form a triangle, but what kind of triangle? 4 squared versus 2 squared plus 3 squared. 4 squared is 16. 2 squared is 4. 3 squared is 9. 9 plus 4? 13. This is an obtuse triangle. Can we use an obtuse triangle to see if it's perpendicular? No. In order to verify that you have perpendicular lines, the triangle would have to be a right triangle, so this would not work. So once again, this is another real-world example, just like when I told you guys about getting hurricane windows and doors and how those doors, they can sway front to back. They can sway left and right. And so there's a lot that goes into making sure that you have an installation that is that has 90-degree angles. Because remember when we learned about stable and non-stable shapes? Is a rectangle a stable shape? No. So when you're installing just the door frame, it is not a stable shape. It has give, it has sway, left, right, front, back. So just like those benches that the football players were sitting on last chapter, a rectangle is not a stable shape. But as soon as you put a diagonal support, or say a window that has glass holding that form, then it is a stable shape, and that's why it's so much easier for them to install windows than doors. So some of this stuff you guys are actually going to use in the real world, which is a good thing. So make sure you don't forget this when you're doing any kind of home renovations, or if you ever decide to get a sailboat or a catamaran, to be able to know that they're installing it correctly. All right, so that's the end of this lesson.